What is the story behind NASA's first successful failure, Apollo 13? And more importantly, how is it possible that 3 astronauts survived traveling to the moon and back with a hole in their spacecraft's oxygen tank after an explosion? Stay with us to explore. The story of Apollo 13 is one of bravery, ingenuity, and the triumph of the human spirit in the face of danger and uncertainty. Launched on April 11, 1970, Apollo 13 was the 7th crewed mission in NASA's Apollo program, and the 3rd intended to land on the moon. Commanded by Jim Lovell, with Jack Swigert as command module pilot and Fred Haise as lunar module pilot. The mission seemed destined for greatness until a catastrophic event changed its course forever. But first, let's see the original plans for the astronauts. Their mission was meticulously planned, aiming to explore the lunar surface near the Fra Mauro crater, a location of significant geological interest. This area was chosen for its potential to provide crucial insights into the moon's early history, offering the possibility of collecting valuable lunar samples and conducting geological surveys. But then, a catastrophe struck. Just 2 days into the mission, an oxygen tank in the service module, or SM, violently exploded, causing significant damage and forcing the crew to abandon their plans for a lunar landing. With the spacecraft crippled and vital systems compromised, the crew, supported by ground control, faced a daunting challenge: to return safely to Earth against all odds. It was a truly life-or-death situation for the crew. If they hadn't managed to repair the life support system, they could have easily run out of fresh air to breathe in the spacecraft. The situation was serious. The lives of the crew were at stake. If they hadn't overcame the issues with the life support system, the carbon dioxide buildup from breathing could have easily suffocated the crew. Mission Control now shifted its attention from landing the astronauts on the moon to bringing them home alive. The initial response to the crisis was swift and decisive. Legendary flight director Gene Kranz and his team in Mission Control devised a plan to utilize the lunar module, or LM, as a lifeboat to sustain the crew's survival. This involved powering up the LM and using its systems to support the crew during their journey back to Earth. It was a scenario that had been considered unlikely but became their only hope for survival. What's more, the crew had to power down all non-critical elements of the spaceship. The fuel cell providing cooling and drinking water for the crew was damaged in the explosion as well, meaning that not only the spaceship's abilities were reduced, but the crew had to cut down on drinking water to save it for spacecraft cooling later in the mission. A key decision was made regarding the return path. Instead of attempting a direct abort, which would have used the service module's main engine to return to Earth before reaching the moon, Kranz opted for a longer route, swinging around the moon before heading back to Earth. This decision, although unconventional, proved to be the right one, ensuring the crew's safe return. Since they powered down most of the systems, some calculations for the trajectory burns were performed in the astronauts' heads, or through the use of a slide rule. But just how powerful were the best computers of that age? Not that powerful, frankly. Apollo-era computers would not stand a chance against today's computing power. Even the phone in your pocket is much more capable compared to the technology used back in the day. The in-space navigation was tricky as well. Since there are no road signs in space, the astronauts had to use the old sailor's favorite tool, the sextant, to navigate by the stars. During the return journey, the crew faced numerous challenges, including the need to adapt the lunar modules, or LM's, systems to sustain 3 astronauts for an extended period. Engineers on the ground devised innovative solutions to bridge the gap, using materials available on the spacecraft like duct tape to create makeshift devices like the mailbox to remove carbon dioxide from the air. Although they solved the most critical problems, the quality of life was quite miserable in the spacecraft. To preserve energy, the electrical systems were periodically deactivated throughout the journey, resulting in the loss of a significant heat source for the spacecraft. Consequently, the temperature plummeted to 3 degrees Celsius, or 37.4 degrees Fahrenheit, creating an environment so cold that sleep became nearly impossible. Furthermore, Lovell lost 14 pounds, while the entire Apollo 13 crew collectively lost 31.5 pounds, nearly 50% more than any previous crew. Weight loss during space missions is not uncommon, but in this instance, it was primarily attributed to dehydration resulting from the limited water supply. As the spacecraft drifted off course, the crew made critical adjustments, including executing precise burns using the LM's thrusters, and navigating using unconventional methods, such as using the Terminator, or the line between night and day on Earth, in order to guide them. However, the most difficult part was still ahead of them, re-entering into the Earth's atmosphere. Despite the challenges they faced, the crew remained resilient and determined. Their journey back to Earth culminated in a dramatic re-entry and splashdown in the South Pacific Ocean on April 17, 1970. The Odyssey capsule hit the Earth's atmosphere at over 24,000 miles per hour, bleeding off energy slowly but surely over the Pacific Ocean to get ready for the parachute deployment. After the first minutes of radio silence, the spacecraft's large main parachutes opened, leading the mission to a soft landing on the ocean waters. Although fatigued and facing health challenges, the crew emerged from their ordeal in good condition, a testament to their courage and fortitude. But who or what caused the explosion and the complete loss of the lunar landing? The problems with the tank had already been identified during testing, yet no modifications were implemented. Components of the tanks were salvaged from previous space missions, but when new thermostatic switches were installed, the wiring remained unchanged, unable to withstand the 537 degrees Celsius, or 998.6 degrees Fahrenheit, heat generated by the new heaters. The extensive testing conducted on Earth inadvertently resulted in the creation of a ticking time bomb, which detonated 2 days into the mission. The successful recovery of Apollo 13 captured the world's attention and earned the crew accolades from President Richard Nixon, who awarded them the Presidential Medal of Freedom, the highest civilian honor. Their remarkable feat stands as a shining example of human perseverance and the power of teamwork in the face of adversity. Apollo 13 remains one of the most remarkable chapters in the history of space exploration, reminding us of the indomitable spirit of exploration that drives humanity to reach for the stars. Would you ever travel to the moon after hearing this story? Let us know in the comments. We hope you enjoyed this episode, and want to thank you for watching. Please subscribe to Orbital Prime and click the like button along with the bell to be notified when we release new episodes.